You want me to wait on that one? It does look like it didn't get full, it's not the
Yeah,
full file size.
yeah, I think the latest one is it's the current one, yeah. The one that was sent at 11:08. The second one that was sent at 11:08. So the correct one's in the chat now.
Grab that. Save, open. There it is. All right, so kind of again, probably good to draw some of these things. If T is the midpoint of RS, so let's draw RS. There's RS, and then they're saying, okay, T is the midpoint, right in the middle. That means that those two are congruent. RT is congruent to TS. That is a definition of a midpoint. Midpoint means
Yeah,
that,
so like so it's in the middle of the
yes,
got it. So wait, so uh let me put the next one. All right, the next one's in the chat.
right there it is. All right, some more stuff. We got some angles this time. All right, what angle relationship best describes angles E to F to C? So this is the angle right here. That's E to F to C. Sometimes it's good to label that. And E to F to D. E to F to D is this one right here. So
Okay.
notice they fall in a straight line. Like sometimes there's these extra lines that you don't need.
So like that, like for example, that line AB, I think.
Yeah, you don't really need that. And it's sort of, so complementary angles add up to 90. Congruent angles are congruent. They equal each other. Vertical angles, they meet at like a
Yeah, because
V or an
it
X.
has been the opposite side of like
Yes.
so yeah. God. Yeah, at first I thought it was complementary angles, but
So complementary would be if they add up to
yeah,
90.
if like both of them would have to be smaller than
Yes.
yeah, that's what I thought. All right. This next one, it talks about non-coplanar segments. Not really sure what that
Non-collinear.
is.
All right, well, we'll
No,
talk about that.
yeah, let me put it in the chat. You'll see it as one of the options there. I think it's the first option that it gives.
All right, there we go. All right, so the presence of a segment bisector will result in what type of segments? Okay, so the idea is that here is a segment, let's call it A to B. And if you bisect it, that means you cut it in half. These are congruent. Now, it doesn't have to be cut in half by a vertical. You could cut it in half, for example, at an angle. It doesn't really matter. What matters is there's a place where you cut it, and these are congruent. So non-coplanar segments, maybe we should talk about what that is, but non-coplanar means they're not on the same plane. So like there's a line there, there's a line there, they're not on the same plane. Parallel segments, they're parallel. Perpendicular are perpendicular, they meet at 90.
Got it. Okay. Wait, so what really is a segment bisector?
It's when it's when it cuts it in half. Cuts
Oh,
something in
got
half.
it. Got it. So I was kind of confused what they meant by it. All right, yeah, that makes sense now, yeah. All right, yeah. All right, let me put number 6. Load up. All right, number 6 is in the chat now.
All right, see it there. Let's download it. Take a look, see what we got. All right, so copy. So this talking a lot about bisectors. Okay, so it says if zx, this one in the middle here, is a bisector of w zy. So that means it cuts the whole angle in half. An angle bisector means that both angles are congruent. Okay, so P equals 35, but is it asking about the whole angle or the angle measure of P? In this case, it's asking about the whole angle. So the whole angle is 35 plus 35.
But how would we know that P is 35?
Because it's an angle bisector, means it's half. This is X and
Got it.
X, and they have to be the same.
So anytime they say bisector, both halves of it will be the exact same
Yeah.
angle. Got it. Yeah, that makes sense. Yeah. Actually, I think I'm gonna do quickly number 7 because it was pretty easy. But here, I'll take a screenshot of it. Just so you can check it. But I was able to draw this one out on paper, so I kind of was able to visualize it. But
Yeah, one of the most challenging parts of the course is drawing these things, especially if you've never seen them before, which could be the case if you don't even have an instructor to lay it out for you. So here you go. If E is the midpoint of AB, so again, probably good to draw. Here's A to B. Doesn't have to be drawn to scale. E is the midpoint, and A to B is 30. So the whole thing is 30. That means each of these are
yeah, that's
15
that's
because
that's what I thought because it has to be exactly it. It's in exactly in half. So half of 30 is 15. So oh, all right, this is number 8. Let me go put this in the chat. All right, it's in the chat now.
okay, let's take a look. Okay, if LR, that's the whole thing, well, why don't I draw it on there? If the whole thing is 12. And this part is 7. What's PR? Well, PR is 5. We know that it must be 5. So it's either the second one or the fourth one. When the question is why? Why are they the same? And this is the segment addition postulate. What that means is that LP, all right, well, they say it right here, LP plus PR equals LR.
Got it.
Right. Now, the other one says that they're the subtraction property of equality. Well, I take this back here. Yeah, okay, no, it is using subtraction. Okay, that does, you do have to end up subtracting, so that looks okay.
Yeah, you need to subtracting. So yeah, yeah, that makes sense. Yeah. All right. I think it's the first one for this, but let's, yeah, let me put this in the chat. Yes, it's in the chat now.
Okay. Let's take a look here. All right, got it. You're always welcome to send these over in advance if that's convenient. Meaning like ahead of the lesson or put them in a document, but this is fine here. So what is the measure of angle A, B, C? So the whole angle measure, and we know that the two individual angles are 15 and 40. So we know if we add them together, that it's 55. Okay, so that gets us down to two answers. All right, so look at A and look at D. What's the difference between them?
Um, well, let's look at D, or the last one. It says using the angle addition postulate, then
Yes,
15 plus
and that,
40.
right. They're not equal. I mean, it's not. I'm sorry. You are adding, but why can you add? Because you can add two angles. So yeah,
Yeah,
I believe it
yeah,
would
and
be this last one here.
and it's not really a bisector either, because it's not the same angle measurement on both of the angles. It's different ones. So yeah, I think it'd be last one. Yeah, well, the first one is that it was. I'm gonna go ahead. I'm gonna go ahead and try number 10.
Okay.
Oh, second. So
I'm gonna step away for 30 seconds to have to check on some coffee, but I'll be right back.
All right, yeah, no problem.
All right, looks like you sent something over here.
Yeah, that's what I think it is for number 10. I already-
Okay, let me grab it here, drop it on the screen. Oh boy, so this is a full-on proof. Okay, these are tough, but that's okay. So these are called algebra proofs. You're just using properties that you already know. So for example, here, the commutative property of addition, this means that you can reorder from line 1 to line 2. Let me show you that because I think sometimes just seeing it isn't as clear. They're just reordering it. They're putting the minus 2x next to the 5. Now you have to look and see, well, what are they doing next? Well, they're combining x and minus 2x. They're adding these
So,
together.
so the like terms.
Like terms, yes. They're combining like terms. So so you got down to those two. So then what are they doing to get to um
They're
the next?
adding x to both sides to get rid
That's
of the
right.
negative x on that.
So there's the addition property like that. And then from there you can do the rest.
Yeah, then you end up with the last part, which is the division property of
Yeah,
equality,
yeah, yes.
dividing 5 on both sides, which gives you the final x equals 2/5. All right, I'm gonna go ahead. All right, so this time we got a 90%, so lower than last time. We got one wrong, though. That was the first question. What is the requirement of supplementary angles? I think the correct answer that they put was the measures of supplementary angles must add up to 180 degrees.
Yeah, you notice we changed that after doing the second one. Complementary add up to 90 degrees, supplementary add up to 90 degrees. So
Yeah.
you'll want to somehow take note of that for your tests to make sure you've got, these problems rework.
Yeah.
Especially that one yesterday where it was with a point in the line or segment in a line.
Yeah. Um, because those are very specific to like what they're asking for.
Yes, yes.
All right. The next one we're gonna go over is line and angle proofs.
Okay.
I do have some notes for this one. All right. So or yeah, so let me just zoom out a little bit so I can get the screenshot. All right. There we go. put in the chat. All right, so it's in the chat.
All right, there it is. All right, there's quite a bit here. So let's see if we can
Yeah, that's why I had to
piece this
kind of
together. Piece this together here. All right, so the are they correct? Right.
yeah, so that gives you
Billion.
two proofs, and then you have to see.
All right.
Yeah, so it gives you
All right. So that you can't it's not a proof. I should say it this way. It's not a proof to just say the vertical angles are congruent. That's not typically a proof. Because you're
But
trying to
wouldn't
prove that.
oh wait, never mind. I was thinking of the vertical angles theorem, which we talked about in the lesson.
So that's what we're trying to prove. We're trying to prove that vertical angles are congruent. So you can't say that vertical angles are
Yeah, that's
congruent.
just kind of just saying that it's congruent instead of
So
really proving it.
let's go through it. It says that angle 1 and angle 2 equal 180. That's fine.
Yeah,
Then it says angle 1 and angle 4 equal 180. So then they set the angles equal to each other. Angle 1 plus angle 2 equals angle 1 plus angle 4, and then they subtract angle 1 from both sides. So that angle 2 equals angle 4. All right.
yeah, that would be that basically what the
So
vertical
I would
angles theorem
I
is
would
kind of
I
showing.
would yeah, I would tend to say that Daniel is correct, but Kelly is not. There is sometimes more than one way to do a proof, but not in this problem, it would appear.
Got it. All right. Let me put this one in the chat.
All right, there's another one. So this one, again, these are getting more involved, and that's to be expected here. All right, so the following are incomplete paragraphs proving angle WRS. So that's this one here, WRS is congruent to angle VQT right here. So those are considered alternate interior angles. Okay. And they are congruent. They are congruent. And they're telling you that UV is parallel to WZ. All right. So let's just go through this. This is according to the given information, UV is parallel to WZ. So you always start with the given. So you kind of just read it. Okay, there you go. That's everything up to there is true. That's great. Angles SQU and VQT are vertical angles. So gonna switch colors here. I don't know if we've done that before. SQU and VQP are vertical angles. So we're up to there. That's good. Angle VQT, that's the one we just did in green, is congruent to angle SQU by the vertical angles theorem. So notice that you can't just say they're congruent. You have to say they're vertical angles, and then you're supposed to say that vertical angles are congruent.
Yeah,
All right. Now, the next thing it says is because angles SQU, let me do that in red. SQU and WRS are corresponding angles. They're congruent according to the corresponding angles theorem. So again, that's true. So here's what corresponding angles are. I don't know if we've talked about it. I guess I'll do it in the same way that they do it here. So angle 1 corresponds to angle 3, 2 corresponds to 4, like that. 5 corresponds to 6, 7 corresponds to 8. They're like in the same relative position. All right. So here's what the proof has said so far. It says that angle SQU is congruent to angle VQT, and angle SQU is congruent to angle WRS. Okay, so since it's kind of like since A equals B and B equals C, but it can also be the substitution. Because you are substituting in for this, but wonder which one they want. So do you see our like you are literally substituting this? Hmm. Do you remember which one they emphasized in the notes? Substitution or transitive?
From the notes back. Just notes. I think it was transitive.
Let's go with that. That's the one we've been using a lot of. The substitution doesn't seem to apply. It does seem to be more like a since A equals B and but you can go back, I guess, the second time if you need to.
Okay. Yeah, this one you have to zoom in a bit because there's questions. It's really big.
Grab it here. So it's like because they've given you so much, that's where I think it's gonna be tough to sort of do. But all right, UV is parallel to WZ. So we know that these lines are parallel. And SQ, R, and T are all on the same line. That's fine. Now the measure of angle SQT is 1/8. So you're saying this is a straight, that's fine. Measure of angle SQV plus measure of angle VQT. So SQV plus VQT. Okay, so they're saying these two angles, and it's like I like giving them like X and Y. X and Y, they add up to the whole thing, and that's true. Is that okay? Clear?
Yeah.
Now, the next one here says, oh, they're asking for what goes in there. Okay, substitution property of equality. Okay, so that's what they want. So you kind of need to go down to the next line, which is that or 6 here to say like, well, what is it? What's going on here? Measure of angle SQV plus measure of angle VQT is one angle. So they're substituting this in here. So it's that the right side equals 180. When they're substituting, they're literally replacing.
God.
So it looks like it's either this one or this one, but it's the same letters. Like all they're doing is putting it in one place. So it's SQV plus measure VQT.
So it would be that one, yeah, because the other one is just as SQV plus
Yes.
SQT. So it would, yeah, all right. All right. This one uses a flowchart proof. All right. Screenshot.
There it is. So you can see that I guess we're moving a little slower through these because they're proofs. So they just take a little bit longer each time. That's okay. Um, Now you don't have to go you don't have to go all the way through the proof, but I do think it's useful um, because it kind of gives you some context about uh, so have you like I would recommend just trying to go through each other.
All right.
Do you see how it kind of starts out the same way the previous one does? They give you a straight line. They tell you the two add up to the whole angle and that the angle adds up to 180. And then they
Yeah.
go over here, they say, okay, well, what else adds up to 180? Well, they use the fact that the two lines are parallel. Two lines are parallel. So VQT. So this one here is VQT and ZRS. These are called same side interior. Same side interior. So they add up to 180. And the reason is that it adds up to 180. Because they're same side interior. But what they're saying is since they add up to 180 and these add up to 180, you can set them equal to each other. So it's like, because this equals 180, because this equals 180, you can set them equal to each other. So if we're looking for a reason here, it's that they are, you're substituting in for 180 again. Like one of them,
Oh,
like instead of this 180, you're putting this in for that 180 down there. So I would say it's a substitution property again.
got it. All right. All right, so this is the last one for this.
Oh, good. We're doing well on time. Oh, is it just 5 for this one?
Yeah.
Okay. That makes sense. They've all been 2 points. So that does suggest that. So I think that we had one earlier though, just to be very, still not quite happy with this one, but, or it's transitive, but we've been using substitution a bunch now. We haven't used any transitives. So I might consider going back, and changing the second one to the substitution. Just because none of them have been.
All right, I think this is number. Oh,
Two.
so I kind of like got the.
I'm not sure though. I hate saying that. I know the grade is in balance here, but
Well, technically, let me just take another screenshot. I don't think this one should cover it. All right, there we go. Now let me put this in the chat. Yeah.
oh boy. Shortage of challenging problems. All right, so let's take a look here. All right. There's so much here. All right, given BC. Okay, so okay, so sometimes you can go down to what's missing. What's missing is that they somehow do something with CED and BED.
Yeah, to make it. Yeah. It's,
Like something happens with those. So we found that CED was 30. So this is really 30. And then BED, where's BED? BED is the same as ABC, so that's 70. So it looks like it's that plus 30 equals 70. And again, we're
minus 30
substituting.
on both sides.
Yes. So
Yeah, that's
actually,
what it started to look like. Yeah.
so I guess I would tell you for sure to go back and change that first one to
Yeah, I
substitution.
think that's what I did. I just went back and there. So, all right. So B. All right. So, all right. Let me go back and yeah, I changed it out to substitution. So good for that one. All right. Let me click. All right. Oh, it was transitive. Oh, second. Oh, yeah, I can see how it's transitive now. Yeah, if I look back at the image of that example for transitive in the notes. Yeah, so that was transitive, and then yeah, it's only wrong question. So that was transitive.
Okay, well,
Yeah, because I think it's key, like when I'm doing the test even by myself, just to look back at the notes, like because like in these tests you are allowed to look back at the notes. So
yeah, I would have all these
uh,
printed out or all them in files that you can
yeah,
look for.
yeah,
They're
because
gonna
like
be,
you, yeah,
they're
because you
just a
could
little bit
like
off.
yeah, you could look back at it, then if you could even see if anything looks similar, and you could kind of help that guide you to towards like the answer. Right? Anyways,
All
I
right,
think
so
that's
this
all the
probably,
time we have for
yeah,
today.
it's probably a good time to play stop. So let me